Spiders can fly without wings. The science of ballooning you never knew. When most people think of flight, they picture birds, bats, or insects like butterflies and bees. Wings are the usual prerequisite for taking to the skies, but nature is full of surprises, and one of the strangest involves spiders. Despite having no wings at all, many species of spiders are capable of flying through the air, sometimes traveling for miles, even across oceans. This remarkable phenomenon is known as ballooning, and it is one of the most fascinating adaptations in the animal kingdom. Spiders that balloon are often tiny, but their journeys can be vast. Scientists have studied this behavior for centuries, and only in recent years have they begun to unravel how spiders manage such an extraordinary feat. What is ballooning? Ballooning is a method spiders use to disperse from one place to another. Instead of walking or climbing, the spider climbs to an elevated point, raises its abdomen, and releases silk threads into the air. These threads catch on air currents or even Earth's electric fields, lifting the spider off the ground and carrying it away. From the human perspective, it looks as though the spider is flying, but technically, it is gliding or sailing on invisible forces. Spiders can rise only a few feet, drift across fields, or in some cases travel hundreds of miles. Ballooning allows them to colonize new habitats, escape predators, and spread their population across large areas. Who does it? Ballooning is most common in very small spiders, such as spiderlings, juvenile spiders, or lightweight species. Many species of orb-weaving spiders, sheet weavers, and wolf spiders practice ballooning. Not all spiders balloon. Larger species, like tarantulas, are simply too heavy to be lifted by air currents, but for tiny spiders weighing only a few milligrams, ballooning is a highly effective survival strategy. A history of observation. People have been noticing ballooning spiders for centuries. Charles Darwin, during his famous voyage on the HMS Beagle, described finding tiny spiders landing on the ship while it was hundreds of miles from the nearest land. He was astonished that such small creatures could travel across vast stretches of open ocean. In fact, ballooning spiders are sometimes responsible for spider rains events where thousands of silk threads fill the air, drifting down and covering landscapes in gossamer sheets. Such phenomena have been documented around the world and often leave people both amazed and unsettled. The mechanics of ballooning. How exactly do spiders manage to take off without wings? The secret lies in physics. 1. Silk threads. When a spider prepares to balloon, it releases extremely fine silk fibers, much thinner than those used for webs. These fibers are lightweight and capable of catching the slightest breeze. By releasing multiple strands at once, the spider creates a kind of parachute or sail. 2. Air currents. Once the silk threads are in the air, they are carried upward by rising warm air currents known as thermals. 3. Electric fields. For a long time, scientists believed ballooning relied solely on wind, but in 2018, researchers discovered that Earth's natural electric fields also play a role. Air near the ground often has a weak electric charge, and spider silk can interact with this field. The silk fibers become charged and repel one another, creating a spreading fan shape that increases lift. This explains how spiders can take off even when there is little or no wind. How far can spiders travel? The distances spiders can cover are astonishing. While most ballooning trips are short, just enough to reach a nearby plant or clear a predator, some spiders have been recorded traveling hundreds of miles. Tiny spiders have been found on volcanic islands in the middle of the ocean, far from any mainland source. Darwin's report of spiders landing on the Beagle while far at sea remains one of the most famous examples. In rare cases, spiders have been documented reaching altitudes higher than airplanes, carried by powerful air currents. This ability to travel vast distances explains why spiders are often among the first colonizers of newly formed islands or recently disturbed landscapes, such as areas recovering from volcanic eruptions. Why do spiders balloon? Ballooning is primarily a dispersal strategy. It helps spiders spread out and reduce competition for food and mates. For baby spiders, ballooning is a way to leave the nest and find new territory. Other reasons include escaping predators. Ballooning allows a spider to make a quick exit from a dangerous area. Expanding range. By traveling long distances, spiders can colonize new habitats and ensure the survival of their species. Seasonal behavior. Some species balloon during certain times of the year, often linked to weather patterns or breeding cycles. Ballooning and the web of life. Ballooning isn't just a curiosity, it has real ecological importance. Because spiders are predators, their ability to spread quickly allows them to control insect populations in new environments. This can affect entire ecosystems. For example, after volcanic eruptions or wildfires, spiders are often among the first animals to repopulate the area, helping establish the food web for other creatures. In this sense, ballooning makes spiders pioneers of ecological recovery. Challenges in ballooning. Although ballooning is an amazing survival skill, it comes with risks. Unpredictable destinations. A spider has no control over where it lands. It could end up in a suitable habitat or in the ocean, where it won't survive. Predators. While floating, spiders are vulnerable to being eaten by birds or other animals. Weather, strong winds, or storms can carry spiders far from land, leading to mass deaths. Despite these risks, ballooning is so effective that evolution has favored it in many spider species. Myths and misconceptions. Because ballooning spiders can appear suddenly in great numbers, they have inspired myths and superstitions. In some cultures, spider rains were seen as omens or supernatural events. Modern science, however, reveals that these silk-covered landscapes are simply the result of thousands of spiders dispersing at once. Another misconception is that ballooning spiders pose a danger to humans. In reality, most ballooning spiders are tiny, harmless species, often less than a few millimeters in size. Human inspiration. Ballooning has even inspired human technology. Engineers study spider silk and ballooning to understand lightweight materials, natural aerodynamics, and even space exploration concepts. Some have suggested that ballooning spiders could serve as models for deploying tiny sensors or devices into the atmosphere using nothing but natural forces. The bigger picture, spiders as survivors. Spiders are often misunderstood and feared, but their ballooning ability highlights just how ingenious and adaptable they are. Without wings, they have evolved a way to conquer the skies, cross oceans, and colonize nearly every corner of the earth. This ability underscores a larger truth: life finds creative solutions. Ballooning shows that even creatures as small and seemingly limited as spiders can exploit physics and Earth's natural forces to achieve something extraordinary. Spiders may not have wings, but that hasn't stopped them from mastering the skies through ballooning, releasing silk threads that interact with air currents and electric fields. They can travel short distances or cross entire oceans. This adaptation has allowed them to spread across the globe, colonize new environments, and survive in places where few other animals could. For scientists, ballooning is more than a curiosity. It's a window into the complexity of nature's solutions. For the rest of us, it's a reminder that even the smallest creatures can achieve feats that defy our imagination. So the next time you see a tiny spider climbing to a high point and raising its abdomen, know that you may be witnessing the beginning of an epic journey, a silent flight into the sky, powered not by wings but by silk, air, and electricity.